So the topic of today's lesson is binomial expansion. So first we're going to look at what does it mean to be doing a binomial expansion, and then we're going to look at the connection between, well, what is Pascal's triangle, then the connection between Pascal's triangle and expanding binomials, and then in a separate lesson we're going to look at what Pascal's identity is and the connection between Pascal's identity and Pascal's triangle. So first off, what do we mean by binomial expansion? Well, what do we mean by a binomial? Going back to grade 9, a binomial is just a polynomial that has two terms in it. So this thing that we've got right here is a binomial. And if we're looking to expand it, what we're doing is we are raising this entire binomial, that's why it's in brackets, to some exponent n. Okay? And then we are expanding it and we are collecting like terms. So the most common one that you guys have done, I think, would be something like expanding to the power of 2. So I might have 2x plus 3y all to the power of 2. And you spend a lot of time in grade 10 and 11 doing this kind of expansion. You learned the good old-fashioned FOIL rule, where you multiplied the first 2, then the outside 2, the inside 2, and so on and so on. So you would expand it, you would collect your like terms, and you would end up with something like this. 4x squared plus 12xy plus y squared. So a series of terms here with coefficients out in front. Okay, coefficients are just the numbers. You've got an exponent on each variable. And of course you've got one, sometimes two variables in each of these terms here. It gets a little trickier if we change this number up here that we're using for our exponent. If we do something like 2x plus 3y cubed, this is still something we could do by hand. We know that this is going to be, 2x plus 3y times what we get by doing FOIL in the first one. So 12xy plus 9y squared, okay? And we could still multiply this out, okay, term by term, collect all the like terms, and get some big long polynomial. But what if we have something like 2x plus 3y to the power of 10 that we want to expand? This would take a long time for us to do. So the question we're asking at the bottom here, is there an easier way of finding the number of terms, the coefficients in each terms, and the exponents that are going to appear on the variables in each one of our terms? The answer, of course, is yes, there is. And that's what we're going to learn here. And we're going to start with this thing called Pascal's triangle. Now, it's called Pascal's triangle because this mathematician, Blaise Pascal, he didn't discover it, but he found a whole bunch of uses for it, and he published them. So he's sort of the most well-known proponent of this triangle, so we call it Pascal's triangle. And you start by, well, how do you make Pascal's triangle? You start, it's got a series of rows of numbers, and we tend to label these rows. So the first row here, we label it row 0. And that's our starting point. And we just put a 1 there. And then the next row is going to have 2 numbers. And you get the numbers in the row below the row that you already have by adding the numbers up above it. Okay? So each of these 1s comes from taking, I'll use, let's see, blue here, saying, okay, if I've got a position right here, what numbers are up above it? Well, there's just a 1 there, so 1 plus 1 gives me 1. What's above this number here? 1 plus 1 just gives me 1. If I go down to the next row, I'm going to have 3 places. We add sort of a new place each time we add a row. If I look at this 2, well, what is above the 2? There's a 1 there and a 1 there. So 1 plus 1 gives us 2. And then in this place here, we just have a 1 and we just have a 1. So let's add a few more rows here to Pascal's triangle. For row 3, we're going to have 1, 2, 3, 4 numbers. In the middle here, if I look at this place right here, we're going to have 1 plus 2 gives us 3. Over here, we've got a 2 and a 1, gives us another 3. And then on the outsides, we're just going to have 1 and 1. And we can keep building this up. Row 4 is going to have a 1 on the outside. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4. And then a 1 on the outside. And this goes on and on. Row 5, we're going to have a 1 on the outside. 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. 4 plus 1 gives us 5. And then a 1 on the outside. Okay. So that's how you generate Pascal's triangle. Okay, so when you're working on problems, you might need to, write it down on a piece of paper. Always start at 1, give yourself 2 1s, and then just start adding as you go down. Okay, what's the connection between doing expansions of binomials, like we have here, and Pascal's triangle? So I've given you a copy up to row 7 there in the corner of the page. Well, let's think about what the expansion is. We're expanding x plus y to the power of n. Well, let's look at a bunch of examples here. Okay? In our first one, we've got x plus y to the 0. So n equals 0. All right? What is x plus y to the power of 0? Well, what's anything to the power of 0? It's just 1. Notice that what do we have up in row 0 of Pascal's triangle? We've got just a 1. If we come down to the next one, we've got x plus y to the power of 1. We could expand this out. It's not particularly interesting. We would just have x plus y. If I was going to throw in the coefficients and the exponents, which we don't normally do, we would have a coefficient of 1 out front, a coefficient of 1 out front there, an exponent of 1 there, and an exponent of 1 there. Okay? So in this case, n equals 1. So if we look at row 1 of Pascal's triangle, what do we see? We see a 1 and a 1. Okay. Let's go down to our next one here where n equals 2. This is our good old FOIL rule here. We could actually expand this one out. We would have x squared plus 2xy plus y squared. Now, there's a couple of things I could add in here. Okay, I could add a 1 here and a 1 here. And now notice what my coefficients are, 1, 2, 1. If we look at row 2 of Pascal's triangle, what do we have? We have a 1, 2, and a 1. Okay? So the numbers that appear in each row of Pascal's triangle are telling us what are the coefficients on the terms of our binomial expansion here. The other pattern that we want to see is what are the exponents doing on here? Well, here I would have an exponent of 1 and an exponent of 1. So on my x, I've got a power of 2. I've got a y to the 1, a y to the 1, and then a y to the 2. So my exponents on each term always have to add up to 2. Let's see if this continues, or let's see how this would continue here. If we go down a row, we're at n equals 3. Okay? The expansion for x plus y to the 3 would look like this. 1x cubed plus 3 x squared y plus 3 x y squared plus 1 y cubed. Once again, my coefficients, 1, 3, 3, 1, are given by these numbers in the third row of Pascal's triangle. And for each one of these, if I add up the exponents on my x and my y, they have to add up to 3. And here we've got an x and a y, here we've got an x and a y. We could imagine that right here we have a y to the 0. Okay, so 3 plus 0 gives us 0. And over here we could imagine that we have an x to the 0. And we usually don't put those in because anything to the exponent 0 is just 1. So let's try to do something here that we couldn't do, well, we could do, I guess, if we had enough time and enough energy. But we wouldn't normally do this expansion, x plus y to the 6. Let's use row 6 here of Pascal's triangle to figure out what this expansion is going to be. We've got n equals 6 here. I know that for each of my terms, I'm going to need an x and a y. Now, how many terms am I going to have? If I look at row 6 here, I've got 1, 2, 3, 4, 5, 6, 7 numbers in row 6. So I'm going to need 7 terms here. So I'm going to have an xy plus an xy plus xy plus xy. That gives me 4 terms. I'll have to go down to the next line here, plus xy plus xy plus xy. Okay, so I know I have 7 terms. Each one of these terms is going to have both an x and a y in it. Now I can put in my coefficients out front. Let's see. Row 6 says my coefficients are going to be 1, 6, 15, 20, 15, 6, and then 1 again. And in each one of these things, in each one of these terms, my exponents have to add up to 6. So I'm going to start with a 6 and a 0. Then I'm going to go 5, 1. Then I'm going to do 4, 2, 3, 3, 2, 4, 1, 5, and then finally 0 and 6. So if I wanted to clean this up a little bit, I could write this as x to the power of 6, ignoring the 1 and the y to the 0, plus 6, x to the 5y, plus 15, x to the 4y squared, plus 20, x cubed y cubed, plus 15, x squared y to the 4th, plus 6, x y to the 5th, plus y to the power of 6. So we can use Pascal's triangle. A, it tells us how many terms we need. It tells us what the coefficients are going to be, and we can use this pattern to figure out what exponents we need here. Okay. Let's try one more example that's just a little bit trickier. Okay. Oh wait, I've got 2 examples here. Well, let's do both of them. We've got Pascal's triangle up at the top. Here's the expansion that we want to do. 1 plus x to the power of 3. Okay. First off, we need to know what is our value of n here. Okay. So we know what row to look at. Well, if our exponent is 3, n is going to be 3 here. And we kind of want to think of this as something, our first thing, which is our 1. Our second thing is an x, all to the power of 3. So if we go to row 3 of Pascal's triangle here, we know that we need 4 terms. Okay? Each of these terms is going to have a 1 and an x in it. So I'll just do 1, x, 1, x, 1, x, 1, and x. Because those are the 2 things that I'm combining together inside there. I'm adding together. What are our coefficients going to be? Let's do our coefficients here in a different color. They're going to be 1, 3, 3, and 1. So 1, 3, 3, and 1. So each of these terms is added to the one next to it. But these numbers here are going to be multiplied. Just to remind us that those are coefficients, I'll mark them in blue up here. What do we do with our exponents? Well, let's see. We need all of them to add up to 3 on each one of these. So I'm going to start with a 3 and a 0. Then so the 3 is the exponent on that 1. 0 is the exponent on the x. Then I'm going to go to a 2 and a 1. Then a 1 and a 2. And then finally a 0 and a 3. Okay? So I'm putting an exponent on the 1 and an exponent on the x every time. And then I can simplify. 1 to the 3 is just 1. X to the 0 is just 1. So this is just, this whole term, first term just becomes 1. My second term becomes 3 times 1 times x, so 3x. My third term becomes 3 times 1, which is just 1, times x squared. And my last term is 1 times 1 to the 0 is just 1, x cubed. So my expansion is 1 plus 3x plus 3x squared plus x cubed. What do we do if we have something like y minus 1 to the power of 4? We do this exactly the same way. We think of this as our first thing, y, plus this second thing. And this second thing is going to be negative 1. Okay, because we always want a plus sign in between these two terms in our binomial. So all of this thing to the power of 4. N is 4, so we're looking at row 4 in Pascal's triangle here. We got 1, 2, 3, 4, 5 terms. Each of these terms is going to have a y and a negative 1 in it. So we'll have a y and a negative 1, a y, a negative 1, a y, a negative 1, y, a negative 1. I didn't space that out very well, so I'm going to go down to another line here, y and negative 1. And all of these guys are going to be added together. I'll put a plus sign out here. Let's do our coefficients here in green. So we're looking at row 4. We got 1, 4, 6, 4, and 1. 1, 4, 6, 4, and 1. And then our exponents always have to add up to 4 because n is 4. So we'll start with a 4 and a 0. Then we'll go to a 3 and a 1, a 1 and a 2 and a 2. Pardon me. 2 and 2. Then a 3. Then a 1 and a 3. 1, 3. And then finally a 0 and a 4. And then we can simplify. If our coefficient is 1, we don't need it there. Negative 1 to the 0 is just 1, so we have y to the 4th, plus negative 1 to the 1 is going to be negative 1 though. So I shouldn't have written that plus there because it's going to be minus. So it is going to be negative 1 for y cubed. Our next term, let's see, negative 1 squared is going to be positive 1. So we're going to have plus there, 6y squared. Our next term, negative 1 to the power of 3 is going to be negative 1 again. So we'll have negative 4y. And then our last term is going to be 1, 1, negative 1 to the power of 4 is just positive 1. And there's our expansion.